I like example 8, I like example 8. So consider a mass sliding up. How can it be sliding up? I guess somebody gave it a big push, and it kept going up for a little while. It's going to come to a stop, clearly, but it's sliding up. A rough, oh, there's some friction, 32-degree ramp. You know what? I think I need to dulp. We're going to be finding a lot of stuff. I gave you a whole page. I think I'm going to hedge my bets. I'm going to do my dulp right here because that lets me still draw a pretty big ramp. Find it? Let's put the block maybe right about there. Now it's sliding up. It looks like A wants me to find the force of friction, B wants me to find the acceleration, C wants me to find the time to stop. So I'm going to kind of put a little dotted line. I guess that's my final position, just to imagine what's going on here. And D wants me to find how far up the slope it went. Okay. And that is 32 degrees. Now what? Oh. This is a job for a free body diagram. What are the forces acting on this block? Get the obvious one. And I said to you, draw MG nice and big, and the MG always goes on the pointy side of the ramp, and that way it's not in your triangle and confusing. But now we pause. Components. I'm going to break this up into MG perpendicular and MG parallel, and color, 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 color. And there's my 90-degree angle. Now, my MG perpendicular doesn't quite look perpendicular. Try and draw better than me, but it's close. What else? Is it sinking into the ramp like quicksand? Is it flying through like Superman? There has to be a normal force, and the normal force is canceling out MG perpendicular. What else? Friction. Which way? All depends on which way this block is moving. Oh, which way is this block moving? So friction's going to be pointing. Cool. Okay. A says find the force of friction. All right. Friction is mu times the normal force. I don't know the normal force. Oh, but look, 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 look. I don't know the force the same size as the normal force. Which force is the same size as the normal force? I know you thought the right one. So it's going to be mu mg perpendicular, which is going to be mu mg... Oh, which trig function was it? Of course it is. How do I remember which one is sine? It's the one that has two lines, parallel sine. Okay. By the way, the other quick way is you could notice that this is opposite and this is adjacent, and cosine is the one that has the adjacent in it, and sine is the one that has the opposite in it. So it's kind of hiding in there too. So it's going to be mu 0.1 times, what was the mass? 6 times 9.8 cos 32. You got a friction force of 4.986522. That there? 4.99 if I round off to 3 sig figs? Or am I wrong? I need someone to nod. Yes? Okay. Newtons. I'll be honest, I only find friction if they make me. Usually, I would, if they asked me to find the acceleration, I would do it all algebraically and not bother plugging in that 4.99. So for B, find the acceleration. I'm going to do a complete generic equation from scratch. Who's winning? Well, which way is this block moving? Is it speeding up or slowing down? So which way is this block accelerating? So I ask you again, who's winning? And this is a little strange. Two winners. Who's losing? No one. Most common mistake, kids go mg parallel, and they're so used to having friction be a loser that they put a negative there. In this case, and you've never ever heard me say friction's a loser. I've always said who's winning, let's get the direction. So it's going to be mg parallel plus friction, and that's going to equal ma. Oh, later on today, we'll have more than one mass. We'll combine this with Atwood machines, and it's going to be m all times a. Okay. mg parallel, two lines. So this is going to be mg sine theta, and then I have plus, and I already have an expression for friction right here. It's mu mg cos theta, and that equals ma. Oh! Cool. What happens here? Turns out in this case the mass cancels. Again, if you're not sure whether or not the m cancels, you don't have to cancel it out. I'm just naturally lazy. I noticed that it canceled, and I smiled because that got the a by itself without actually having to get the a by itself. So the acceleration is going to be g 9.8 sine 32 plus mu 0.1 9.8 cos 32. Oh, we did one last day where the g canceled. The g would cancel if there was also a g over on the right hand side. This time there was not. I know it's going to be less than 9.8. 9.8 sine 32 plus 0.1 times 9.8 cos 32. Making sure I typed that right. Looks good. Do you get 6.02429? That there, 6.02? Yep. Meters per second squared. Martin, what does part C want me to find? I'll bet you I'm going to use the acceleration for that. What does part D want me to find? I bet you I'm going to use the acceleration for that. And so what I'm going to do is I'm going to write a few extra sig figs. You know what? I think a nice place to round off is on that second 2, because what's right next to that second 2? You know what? Let's go 6.0243. That gives us 5 sig figs and some breathing room. So just in the margin somewhere, I would make a little note A equal. I would put a box around this one. There's my 3 sig fig answer. But I would make a little note for further use, 6.0243. 6.0243 meters per second squared. That's going to be handy. Martin, what did you say part C wants me to find? Have we done one like this before with ramps and stuff? Say no. I'm going to fall back on my old physics 11 method. T equals question mark. I'm going to make a little note that I do know that A equals 6.0243, although I'm going to try and use my answer button. What else did I've scrolled down. The question had to give me some more information, I hope. Yeah. Oh, they gave me a VI? What was VI? That's only 2 things. I need 3 things to find the 4th. Yeah. Oh, time to stop. Getting here is physics 12, but now that we're here, I would argue this is lovely physics 11. Martin, which equation? Can you get the can you get the T by itself? Yeah. My physics 11 are just plunging. Physics 11s are plunging feet first into that right now. This weird formula manipulation, but they're buying it, which is nice. It's a much better way to do stuff. So 0 minus 20 divided by, I'm going to write 6.0243. I'm going to use my answer button. Try this. Something weird happens. What? Time can't be negative. We must have done something wrong. Okay, now we went back to the last unit, and in the last unit, if we were slowing down, how would we have described that acceleration in the last unit? We will have to add our own negative there. Or, to be honest, if you're really lazy, you could say, I forgot to add the negative and just take the positive value for time. But I did want to explain why that's the case. So 0 minus 20 divided by negative answer button, if I was really paying attention. And I get 3.32. Cool. David, what did D want me to find? Which variable would how far up the slope be in our physics language? Velocity? No. Just even more basic. D. It's not X or Y. What we've decided here for ramps, it's just easier to go along the ramp. And then if we do that, we don't have to do components once we break gravity into its components. Much nicer. We could, by the way, do it the other ways as well, but then there'd be trig through everything. Ugh. So D. Can I get to D using A, VI, and VF? Yeah. I could also use this time value and use D equals VIT plus a half AT squared. No matter what, we're going to be using something to find something. We're at that stage now where there's just no workaround. So I'll be honest, I would probably choose to go with the laziest method. I might use D equals VIT plus a half AT squared. So it's going to be 20 times, I'm going to write 3.32, but I'm going to use my answer button. Make sure that if you're going to use your answer button, your time is positive. If it was negative still on my screen, how could I quickly turn it into a positive? Multiply it by, just multiply it by -1, and now you've got it stored as a positive value, right? Or put a negative in front of it manually. Plus 0.5, negative 6.0243, 3.32 squared. So where my two time values are, I'm going to use my answer button. 20 times answer button plus 0.5 times negative 6.0243 times answer button squared. By the way, if we were sliding down the hill, we'd probably be speeding up, and that acceleration I would call positive. Even though I said down the hill, I think we would find it easier to call that positive. You get 33.2? Or not? Yeah? So questions that you can do, I already said you could try number 1, skip A. Try number 2, skip A. 3 is good. 4 is just asking you to write a generic equation. 5 is good. What's number 6 asking you to find? How would I find an angle? Second function sine or cosine or tangent. We're behind schedule, and so I'm not going to ask you to find angles this year. So we're going to skip question 6. We're going to skip question 7. Eight is good, but cross out A. Cross out B. Just find the acceleration and the time to stop. What's number 9 asking me to find? Hey, what's mu? I haven't done one like that with you. It's going to be just what you and I did, Martin, but instead of getting a T, you're going to get the mu by itself. Now, the tricky part with number 9 is I think you're going to have to figure out A and use that to figure out mu. And you'll figure out A, I think, by using stops and 4.06, and you can find A. 11 is good. 14 is good. 15 is tougher than I'm going to ask. But you can try that one. So here's what 15 is saying. If this mass is to remain stationary, there is a coefficient of friction of 0.6. Right now, this mass will slide. If it's to remain stationary, find the maximum value of x, find the minimum value of, maximum value of f, find the minimum value of f. Let's think about this for a second. The minimum value of f, if I'm barely pushing at all, which way is this going to want to slide? Down the ramp, so which way would friction be pointing? Up the ramp. That's how you'll find the minimum value of f. The maximum value of f, if I'm pushing really, really hard so that this is still at rest but it wants to slide up the ramp, which way would friction be pointing? That's how you'll do that question. You're going to look at it two scenarios and you get two different forces. You'll get the minimum force you have to push with to keep it there and the maximum force you could push with before it would start sliding up. And you'll get an f by itself. Mark your own. Here we go. Oh, got to put my favorite student on here. A book is sitting on a level desk. Like that. Which of the following statements are true? There are no forces on the book since it's not accelerating. True or false? The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. The net force on the book is equal to 0. Is it accelerating? Then that's true. That's Newton's first. Friction is what's holding the book on the desk. Yeah, in fact, if that desk was made of ice, as long as it's dead level, it can still rest on there. 2 marks, half mark for each of those. Find the acceleration of the entire system if mu equals 0. This is a job for a free body diagram. I'm going to have m1g, normal force number 1, tension, m2g, normal force number 2, tension, and here is F applied. I didn't really format this good for spacing. Who's winning? F applied. And then I have minus tension plus tension. Does m1g show up in this equation? I'm just writing forces along the rope. m1g won't show up unless I introduce friction, because friction is affected by the mass and gravity. So for now, I have F applied minus tension plus tension equals m1 plus m2 times A. So A is going to be F applied divided by m1 plus m2. It's going to be 24 divided by 8 plus 12. I can do that in my head. 24 divided by 20 divided by 4 divided by 4. It's going to be 6 over 5. 1.2 meters per second squared. 2 out of 2 if you got that. Otherwise, I would probably go something like a half mark for that equation, a half mark if I saw that, half mark for the numbers, and a half mark for the answers. Find the tension. I would use mass 1, because if I use mass 1, who's winning? Tension. Who's losing? No one. Tension equals m1a. It's going to be 8 times 1.2. 8 times 1 is 8. 8 times 0.2 is 1.6. 9.6? 2 out of 2 if you got that. Otherwise, 1 mark, half mark, half mark. Did anyone use the second mass? Yeah? Did you get the right answer? Okay. Yeah. Got the same answer both ways? Got a little nerdy smile because then you knew you were right? Number 3, same question, but let's add friction. I'm just going to add to my free body diagram. So now I'm going to say, oh, friction force number 1, friction force number 2. And so now I get an equation, F applied minus tension minus friction force number 2 plus tension minus friction force number 1. That's going to be M1 plus M2, or M all times A. A is going to be F applied all over M1 plus M2 minus friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. Another force the same size as the normal force. And this is where the M2G and the M1G show up when there's friction. Mr. Dueck, does that mean that first mass, when it's on ice, makes no difference at all? Well, please notice you're also dividing by that first mass, which gives you a smaller answer. It's still slowing you down. A bigger mass down here would give you a smaller acceleration. So you still are having to overcome the object's inertia, its mass, but you're not having to overcome any other outside forces. 24, 8, and 12, and 0.12. 24 minus 0.12 times, was the first one? 12 times 9.8 minus 0.12 times 8 times 9.8. Did I make a mistake? Oh, that's right, because 24, it won't go anywhere. And I was too lazy to retype the whole exam, so I just changed that. All over 8 plus 12. 50 minus 0.12 times 12 times 9.8 minus 0.12 times 8 times 9.8, close bracket, divided by bracket 8 plus 12, Mr. Dueck. Do you get 1.32? Meters per second squared. 3 marks. 1 mark for that, 1 mark for that, half mark for the numbers, half mark for the answers. Find tension. Again, I used mass 1 because for mass 1, tension minus friction equals M1A. I think that's the easiest one to go with. Tension equals M1A plus friction. Tension is going to be M1A plus mu times the normal force. I don't know the normal force. Oh, but look, and another force the same size as the normal force. So it's going to be 8 times 1.324 plus mu 0.12 times 8 times 9.8. You get 20? That's a complete fluke that it worked out that nicely, but we'll take it. I wrote 20.0 to go to 3 sig figs, but I'm not going to be fussy. Half mark, half mark, half mark for the numbers, half mark for the answer. Elevator questions, not the yucky elevator question that some of you were wrestling with from the, I think, the friction lesson, or lesson 4, the many body problem. There was one nasty one in there. There's going to be an elevator question like this on your test. I like this question, I like this question, I like this question. This is a job for a free body diagram. The key idea behind a person in an elevator is you have gravity down and then you have a scale pushing up. But what does a scale measure? So you really have a normal force pushing up. In diagram A, we're accelerating up, so I know normal force is winning. It's going to be normal force minus mg equals ma. In diagram B, we're accelerating downwards. I can still use this same diagram and just modify it. Who's winning if we're accelerating downwards? Yeah, it's going to be mg minus fn equals ma. Let's get the normal force by itself here. Normal force is going to be ma plus mg. Going to be 60 times 1.2 plus 60 times 9.8. You get 660 for answer A. Newtons. For answer B, I'm going to do the swappy dance, plus the normal force over, minus that over. Scale that reads the normal force in what? So, but if you divided it by 9.8, the scale would read 67.3 kilograms, which means this person's feeling slightly heavier. Not much. mg minus ma. If I was really lazy, nope, that's not what I wanted to do. Dope, I totally botched that. It's going to show you a shortcut because this is almost the same equation. I was just going to put a negative in front of the MA and it would have worked great, but I hit the wrong button, so I got to type it from scratch like a peasant. Ugh. mg 60 times 9.8 minus 60 times 2.25. You get 453? Are we still waiting for some Timbits? Must be getting close to lunch. What's the normal force if the elevator moves up at a constant velocity? If we're moving up at a constant velocity, who's winning? If we're moving up at a constant velocity, who's winning? No one. It's a tie because constant velocity. I'm not moving up. I don't care. It's a tie. So I can safely say normal force equals mg. So it's going to be 60 times 9.8. I should be able to do that in my head. 60 times 9 is going to be 540. 60 times 0.8 is going to be 72. 540 plus 72, 612? Maybe I'm wrong. No, it can't be 612, Mr. Dueck. 588. Wow, way off. In a slump. What would the normal force read if you were in free fall? You could do a lovely proof, but if you just said 0 newtons, that's fine. If you wanted to do a proof, you would say, who's winning? Gravity. Who's losing? Normal force. What's A? Also 9.8. And if you go winner minus loser equals MA, you'll find the normal force has to be 0. Can you give yourself a lovely score out of 19, please?